This presentation is to acquaint and assist maintenance personnel in preventative maintenance, rebushing, and rebuild of the Hendrickson equalizing beam and related parts, including the cross tube and torque rods. These components are part of the one basic design of most Hendrickson series tandem suspensions. Proper service and repair is important for the safe and reliable operation of the Hendrickson tandem suspension. The service procedures recommended by Hendrickson and described in this presentation are effective methods of performing maintenance. In the Hendrickson beam series, there are no adjustments required for alignment. Alignment control is provided by installation of the suspension frame hangers in frame hole drilling jigs by the original equipment vehicle manufacturer. And the equalizing beam hanger brackets are welded into position in production fixtures by the axle manufacturer. Rubber bushings in the equalizing beam centers and ends, as well as the torque rods, permit the oscillating movements of the tandem without friction or metal-to-metal contact. During assembly, the rubber is elongated and inserted between the inner and outer metals of these bushings, creating a high pressure on the rubber which prevents slippage when subjected to torsional deflections. This design restricts excessive movement, but allows sufficient movement to relieve stresses on the metal parts in cornering. Thus, you get maximum flexibility, but can eliminate the necessity of lubrication. The two torque rods, together with equalizing beam and connecting parts, make up a parallelogram-type linkage. This parallelogram arrangement assures positive axle alignment. Axle centers at the wheels always remain equidistant and therefore parallel. On turns, the rubber-bushed joints perform another function. Through their elasticity, each axle aligns itself independently on turns. The rubber bushings allow a certain amount of in and out movement of the axles from the start to completion of a turn. This self-alignment feature permits each axle to follow its own natural course more closely. Once a straight line track is resumed, the action of the bushing squares off the tandem so that the leading tires set the tracking pattern for the rear tires. Now, this has a very positive effect upon tire wear. Proper preventative maintenance programs will help control repair costs and downtime. This is important for safe and reliable operation. For example, all new equipment should be given an initial pre-service inspection. This would include checking all tightening torques of the Hendrickson tandem suspension as specified by the truck manufacturer and is listed in the tightening torque specification chart in technical publication 17730-190. It is also recommended that tightening torques be checked with a torque wrench on a set preventative maintenance schedule. Frequency of this schedule should be determined by the equipment supervisor with knowledge and experience of the type of operation and mileages involved. Preventative maintenance under operating conditions for the end bushings should include a check of the fastener torque with a torque wrench. It is recommended for new or rebuilt units to check at 1,000 miles for an off-highway or for a severe service unit, and at 10,000 miles for on-highway service. Do not over-torque. When it is necessary to have a vehicle in the shop for major repair work or preventative maintenance service, place a jack under each beam end to check for movement of rubber end bushing inner metal. This movement cannot be eliminated by tightening the fasteners due to excessive wear to mating parts and increasing clearance tolerances. If movement is noted, do not operate vehicle. Replace rubber end bushings and all connecting parts. Periodic visual inspection by the driver and service personnel is also recommended. Look for the beam being lower in the hanger or distorted or frayed rubber. Off-highway or severe operating conditions require more frequent inspections than on-highway service. The gap on each side of the visible rubber at the lower end of the end bushings is normal and not an indication to replace bushings. Because all rubber end bushings are in compression with the load bearing on the top side, the lower side of the rubber is relieved slightly, allowing the rubber to move inward and a gap appears. To check wear on bronze ball and socket end bushings, each beam end must be raised with a jack. Movement of 1/8 inch or more before the axle is raised indicates excessive wear, and units should be rebushed. This condition will not affect alignment or tire wear. Lubrication interval depends on type of operation. Severe operation will require lubrication each week. Raise each beam end with a jack to assure complete lubrication. Rubber center bushings. The rubber center bushings control the lateral movement of the axles, which can be up to 3 inches under load. The service life of the rubber center bushings depends on the type of operation. Normal wear is evidenced by the shredding of rubber from both ends of the bushing. A worn bushing will allow increased lateral movement of the axles on turns beyond the 3 inches and allow the inside dual tires to rub on the suspension frame hangers. This is a warning that the center bushing should be changed before serious tire damage results. Bronze center bushings are standard in Series 440, 441, and 450 and optional in most other series. They are not available with the RU, RUE, and UUE series. They are recommended for use on vehicles negotiating frequent tight turns or backing into positions such as dump, transit mix, and refuse operations. The cross tube connects the two equalizing beams through the inner metal of the beam center bushings. This tube restricts the side movement of the axles on turns. The cross tube has clearance to float in the inner metals of the center bushings. In cornering, it is clamped in position, maintaining suspension alignment. The length of the cross tube will allow side float of approximately 3 inches. For this reason, the cross tube will appear polished at each end at entry into center bushing inner metal. A cross tube seldom requires replacement, usually only when it has been bent, possibly due to hitting an unseen object. A bent cross tube will cause misalignment of the axles and must be changed immediately to eliminate abnormal tire wear. The length of torque rods is determined by the truck manufacturer for optimum drive line angles. The torque rods control these angles and also absorb driving and braking forces. On torque rods with attaching ends, designated straddle mount, the axle brackets supplied with axles and frame brackets have 2 mounting holes to attach to the torque rod end. The mounting bolts are supplied by the truck manufacturer. It is important that the tightening torque of the nuts be checked on PM service. Obtain tightening torque specification from the truck manufacturer. There are several ways to inspect torque rod ends for looseness, torn or shredded rubber. 1. Slowly rock the vehicle with power, tractor without trailer, while a mechanic visually checks the action at both ends. Or 2. With vehicle shut down, a lever check can be made with a long crowbar placed under each end of rod and pressure applied. Replacing rubber beam center bushings. Equalizing beam center bushings for the Series 340 through 450 are available with the end plug as a separate item. These center bushings are designed for ease of installation with Owatonna Tool Company equipment when only the center bushings require replacement. This job can be done without removal of beams or wheel assemblies on the vehicle. The end bushings can also be pushed out and replaced with OTC equipment. Major rebuild of suspension. When a major suspension rebuild is required after blocking the tires of the front steering axle and both tandem axles to prevent vehicle movement, remove the tandem axles and equalizing beams as a complete unit. Have floor space behind unit to roll the tandem axles out from under the frame. Drain the vehicle air system. Disconnect all air lines leading to the rear axle, marking the lines for later assembly reference. Unlock all spring brakes on the tandem axles. Disconnect the drive shaft from the front of the forward rear axle. Remove bolts and disconnect both torque rods from the axle brackets. Remove the saddle cap nuts and washers from each side of the vehicle. Then remove the saddle caps. Raise the rear of the vehicle frame and roll the axles with equalizing beams attached out from under the vehicle. Replace the nuts on the saddle lower studs to protect threads. For the removal of the adapter type beam end connection for the 340, 380, and 440 series adapters, removal can be accomplished with the Owatonna tool number 1745 or the use of an air chisel. In either operation, it is recommended that a penetrating oil be applied to all beam end connections. Remove through bolt. The adapters have 2 chisel entry reliefs located in the flange. With air chisel, turn the adapter to locate reliefs for chisel entry. If the adapter does not turn, use a hammer to wrap the outside of the axle bracket leg around the adapter area and repeat with air hammer chisel. Use chisel entry. When adapter has space between axle bracket and the adapter flange, use a bent chisel to wedge and force adapter out. Support the end of the beam as it may drop on removal of the opposite adapter. Whether adapters are removed with special tooling or with the air hammer chisel, discard. Do not reuse them. For the tube and nut connection 340-440 series removal, use a penetrating oil on each side of the axle bracket legs. Remove the tube by using hydraulics with the OTC hanger tube removal set number 1743. Other shop methods are: remove the two tube nuts, use a spacer bushing between the hanger legs and one nut, tightening the nut to pull the tube loose. If this method does not loosen the tube, use a powered portable reciprocating hacksaw and saw through the tube along the inside surface of both axle bracket legs. Be sure to support end of beam as it may drop when the tube is sawed through. For the 3-piece 450 series adapter type connection removal, no special tooling is available. It will be necessary to use the air hammer chisel method suggested previously. The procedure for removal of the ball and bronze socket connection for the 441-444 series is the same, except that the cotter pins must be removed from the nuts and the through shaft on each side of the axle bracket. If the nuts are rusted to shaft, chip them off with an air hammer chisel. If the through shaft is rusted to the axle bracket and beam ball, use an air hammer with a blunt end punch to drive it out. If unsuccessful, use a powered portable reciprocating hacksaw and saw through the beam ball end shoulder shaft on each side next to the spacer. Do not damage spacer end surfaces. When the ends of both equalizing beams have been removed from the axles, the beams can be separated from the cross tube by pulling them apart by hand. The torque rods should then be removed from the cross member. Whether the ends are straddle mount or taper stud, they can be renewed by pressing out the worn end and installing a cartridge type replacement. Use shop press to push out old torque rod bushing. Clean and inspect torque rod end, apply lubricant to torque rod hole, and replacement cartridge bushing. Press in the new torque rod bushing. A 2-piece torque rod, maxi rod, is also available to cut and weld to desired length. Beam rebushing. When removing beam bushings, cut the protruding rubber off one side of each beam end bushing to permit clearance for pushing tool. Use the OTC tool set number 1743 or shop-made tool for series 340 through 450. The rubber is removed so that the pushing tool can rest directly against the outer metal of the bushing. The bushing assembly can then be pushed out of the beam end bore. This is a chart of pushing tools that can be made from standard tubing. The tools will remove and install rubber end and center bushings from all series 340 through 450. Tool numbers 3 and 4 will also remove and install bronze center bushings. Bronze end bushing removal. After removing the 2 bolts that key lock each bronze bushing assembly to the equalizing beam with hardened washers, the beam end can be placed in the vertical press supported sufficiently on both sides, and the bronze socket and ball can then be pressed out of the beam. On the rubber center bushing removal, before attempting to use tooling, inspect the bushing outer metal for any mushrooming over the beam hub. It will be necessary to remove that portion with a chisel or disc grinder on the pushing tool side for even tool contact. Make sure that the beam is squarely supported at the center bore area on the press bed for safety and to avoid bending the equalizing beam. For bronze center bushing removal, the Owatonna tool set number 1744 contains removal and installation tools for series 340 through 450. They also center the bushing and the bore with clearance on each end for grease seal. Tools for installing the seals are included. Shop-made tools will also push the bushings out. Before using either tool, remove the seal on the pushing side of the beam hub. The axle brackets for the beam ends should be cleaned and inspected. Any burrs or material left there by old adapters should be removed. Use a new adapter as a gauge for fit. being sure it enters the holes in the outside of each bracket leg. The equalizing beam bores, torque rods, and cross tubes should all be inspected closely for nicks, metal buildup, cracks, or excessive wear. On the equalizing beam bore, if torch undercutting is found, replace with a new beam. Replace the whole torque rod assembly if the shaft is bent. If there is any doubt as to fracture, wear, or straightness of the cross tube, replace it. The outer metals of all Hendrickson rubber bushings are covered with a phosphate coating which acts as a rust preventative. Before installing new bushings, clean the outer metals with emery cloth and apply a coating of white lead or grease to facilitate the pressing of the bushing into the beam bore. With the equalizing beam supported on the press, lubricate the beam bore and the bushing and place the bushing at the beam end bore. For rubber end bushing installation, use the OTC tool number 1743 to compress the rubber for contact with the end of the outer metal. Push the new end bushings into the beam. Center all end bushings in the beam. An equal amount of outer metal must extend beyond both sides of the beam hub. The only exception to this is the 450 series with a 6-inch long end bushing. It must be installed with the end bushing offset 3/16 of an inch toward the center line of the chassis. Inspect and lubricate the center bore. For rubber center bushing installation, use OTC tool number 1764 or a shop-made tool. When pressing all rubber bushings into beam bores, the pushing tool must be in contact with the outer metal of the bushing. Rubber center bushings are available with a loose plug for use with OTC portable hydraulics. Bronze beam bushings can be installed in the bushing bore in the same manner that the rubber bushings are installed. The OTC tools will center the bushing in the bore and press the two seals into position. If using shop-made tools, the bushing must be centered in the beam, allowing equal space on both ends of the bushing for placing seals in position. On bronze center bushings with seals, the seals must be inside the beam hub surface 1/16 of an inch, or they will be damaged on installation into saddle with thrust washers. Apply chassis grease to bronze lining of bushing. When rubber center bushing equalizing beams are being converted to bronze center bushings, it is necessary that the inside of the beam center hub be tapped for the installation of the lube fitting. For ball and socket end bushing installation, the bronze socket halves with the beam ball should be lubricated and the outer diameter of the bushing and the beam bore coated with white lead or grease. The split of the socket halves must be aligned with the two lock bolt holes in the beam. The bronze sockets are machined as matched pairs and must be used together. Using the counterbore holes in the beam as a guide and a counterbore tool, press bushings in. Counterbore the bronze sockets to the same depth, that is 3/16 of an inch, as shown in this slide. Do not increase the counterbore depth in the beam. Counterbore the bronze socket on both sides of the beam. Install grade 8 bolts with hardened washers under bolt heads and lock nuts. The washers key the bushing to the beam. The tightening torque of the lock nut is 55 to 65 foot-pounds. Installation of rebushed beam. In the installation of rebushed equalizing beams to the axles, first apply anti-seize compound to the holes in the axle bracket legs. Then insert the cross tube into the center bushings intermetals of both equalizing beam rubber center bushings. For bronze centers, first apply chassis grade lube to the bushing and center sleeve. On the 3-piece adapter type installation, apply an anti-seize compound to the inner and outer surfaces of the intermediate tubes and insert them into all 4 rubber end bushings. Position one end of both beams using a floor jack with a support for beam ends and position the end bushings inside axle bracket legs of the same axle. On all 3-piece beam end adapters, apply anti-seize compound to the adapters. Install an adapter in the wheel side first. The bowl side adapter should be installed with a bolt and washer, taking advantage of the cut-off flange to clear the axle bowl. Install washer and nut and start on thread. Do not tighten. Install adapters to opposite bracket and beam end in the same manner. Remove jacks and raise the opposite two beam ends to the other axle and install adapters, bolts, washers, and nuts. All three-piece adapter assemblies must be installed with intermediate tubes. On all three-piece adapters, a split ring adapter is available where a lack of clearance will not permit use of a standard adapter. The flat on the beam end adapter flange must be in a vertical position when the nut and bolt assembly is secured. For 340 through 440 series adapters using a 3/4 inch diameter bolt, tighten nut 210 to 240 foot-pounds torque with axles in normal operating position. Do not exceed specified torque. If the tightening torque recommended is not achieved, metal surfaces will work and wear the axle bracket legs, holes, adapters, and inner metal of the rubber bushing. Properly tightened connection ends will eliminate costly repair, downtime, and possible separation of components and loss of vehicle control. For 450 series adapters with a 1-inch diameter bolt, tighten nut 445 to 495 foot-pounds. Do not exceed specified torque. They are available for 5 3/4 inch and 6-inch length heavy-duty beam end bushings. For tube and nut beam end connections, tighten the nuts 375 to 425 foot-pounds torque. When properly tightened, the nuts will partially flatten against the beam hanger legs, clamping the end bushings. For bronze ball and socket beam end connections, coat all mating surfaces with an anti-seize compound. Install the through shaft and nuts and tighten 500 to 550 foot-pounds torque. Install cotter pins. Do not back off nut to insert pins. If cotter pin holes do not line up, nut may be welded to the shaft. With the beams attached to axles, roll under the center of saddle, making sure center bushings of each beam are lined up with center of saddle legs. Lower frame centering saddles on beam center bushings. Install saddle caps, washers, and nuts. Do not tighten. The nuts on the saddle cap studs are self-locking and should be replaced once removed, as removal could have damaged the locking feature. Install the torque rods to axle brackets and frame brackets. Follow truck manufacturer specifications for fasteners and tightening torques for all straddle mount ends. For tapered stud installations, bracket holes must be free of all foreign matter. Place stud in bracket, install nut, and tighten 175 to 225 foot-pounds torque. After tightening, wrap bracket with a hammer and retighten to same torque. With the weight on the center bushings, torque rods installed, and nuts tightened, tighten the saddle cap stud nuts. The RU, RUE, UE series suspension's tightening torque is 125 to 145 foot-pounds. All other series suspensions from 340 through 450 require a tightening torque of 225 to 275 foot-pounds for the saddle cap stud nuts. Maintain an even gap between the saddle caps and the base of the saddle legs to avoid possible distortion of the cap and bending of studs, which may result from loose caps. Proper service and repair is important for the safe and reliable operation of the Hendrickson tandem suspension. Before service is performed, it is important that the service instructions and safety warnings, as covered in technical publication 17730-190, be understood. These warnings cover restrictions on the use of aluminum components, harmful effects of using a cutting torch for removal of components, and other safety-related items. Do not modify or rework parts. Use only genuine Hendrickson parts for servicing the suspension. Most Hendrickson parts can be identified by the Hendrickson H symbol.